Hi, I am Sagar. In this video, we will discuss solution for few previous year gate questions on logic gates. This question asked in GATE ECE 2015 set 1 2 mark numerical answer type. All the logic gates shown in the figure have a propagation delay of 20 nanosecond. Let A is equal to C equal to 0 and B equal to 1 until T is equal to 0. At T is equal to 0, all the inputs flips means A equal to C equal to 1 and B equal to 0 and remain in that state only. So for T greater than 0, the output Z is equal to 1 for a duration of in nanoseconds. Now this input for this NOT gate is B, the output is B complement. Then assume that output of this NAND gate is Y. So now the input for this XOR gate C and Y, and the input for this AND gate is A and B complement. The propagation delay of each gate is 20 nanosecond. Till T is equal to 0, A equal to 0, now A is equal to 0 and C is equal to 0 and B equal to 1. This is the A, B and C. So till T is equal to 0, A equal to 0, B equal to 1 and C equal to 0. At T is equal to 0, A and C become 1. Now A become 1 and C also become 1 and B is the 0. So at T is equal to 0, A become 1, C is 1 and B is the 0. So remains in that state only for T greater than 0. At T equal 0, B equal to 0. Now the NOT gate output B complement is the 1. Now so at T is equal to 0, B become 1 to 0, but the NOT gate required 20 nanosecond to get the proper output. So now this is the B complement. Now B complement is, so till now it is 0. So here also till 20 nanosecond. After 20 nanoseconds only that B complement equal to 1. So it required at least, here the propagation delay is the 20 nanosecond. So 20 nanosecond. So at T is equal to 20 nanoseconds only, the B complement equal to 1. At T less than 0, A is equal to 0 and B complement. Anyway, if one input is 0 for this AND gate, the output Y also 0. So till T equal to 0, so that output Y also 0. Even at T is equal to 0, A become 1 and B become 0. Now here one input is 0, at T is equal to 0 second also, 0 nanosecond also, B is 0, A equal to 1. Till that AND gate output is 0. Now see at T is equal to 20 nanosecond, the input for this AND gate A is 1 and B complement also 1. Both are 1, then output of this AND gate equal to 1. But that output will be updated only after 20 nanosecond propagation delay. So now here after 20 nanoseconds only the output become 1, Y equal to 1. So now this is the 40 nanosecond delay. So here required another 20 nanosecond to become Y equal to 1. So now see at T is equal to 0, the Z also 0 because Y is 0 and C is 0, both are 0 for XOR gate, so that Z also 0. So T less than 0, Y is equal to 0, C is equal to 0, so both are 0, the XOR output is equal to 0. If both are 0, the output Z is equal to 0. So output Z is equal to 0 till T equal to 0. So at T is equal to 0, the C become 1, so C become 1, so Y is 0 only, so 0 and 1. So at T is equal to 0, C equal to 1, then the output of this XOR gate is equal to 1. But it required 20 nanosecond to get the output Z. So now it required 20 nanosecond. After 20 nanosecond, then the output is 1. So here is the 20 nanoseconds. Now see here at 20 nanosecond, if you observe, so Y is 0, C is equal to 1. then the output is 1. Here also y is equal to 0, c equal to 1. So at 40 nanosecond, what happened? The output y become 1. Output y become 1. So this is at 40 nanosecond. At 40 nanosecond, output y become 1, then c equal to 1. Both are 1 at 40 nanosecond, then z become 0. If both inputs are 1, then the output is 0 for this XOR gate. But it required another 20 nanosecond to update this outputs. Now this at 60 nanosecond. Now this is the at 60 nanosecond. So now if you observe that output z is equal to 1 from t is equal from 20 nanosecond to 60 nanosecond. So this period, nothing but, so the duration is 40 nanosecond. So this 40 nanosecond, the z equal to 1. So that option, so this is a numerical type answer. So answer is 40 nanoseconds. It's very simple problem. So this question asked in ECE 2011, 1 mark MCQ. The output y in the circuit below is always 1. So now that output y is equal to 1. So you need to check 2 or more of the inputs PQ are 0, or 1, or any odd number of inputs PQR is 0, or any odd number of inputs PQR is 1. So anyway, we will simplify this circuit. Now here this is an AND gate. So inputs P and Q. So we will get PQ complement. So the input to this NAND gate is Q and R. So QR bar. So for this NAND gate, input is R and P. So now we can write P R bar. So now it is another NAND gate. So we can write output of this NAND gate. So PQ bar, QR bar and OL bar. Anyway, it is a NOT gate. This is the NOT gate. So two inputs are same for this and AND. Then it acts as a NOT gate. Clear? So now this is the input. This is the input for this NAND gate. Now output is we can write so PQ bar into QR bar. Anyway, the complement and complement cancel. We'll get PQ bar into QR bar. So this is another input PR bar. So now that expression we can write the for y is equal. So PQ bar QR bar into PR bar. This is an AND gate, so whole complement. So now we can write this y as a, so if you use De Morgan's law, so we can write PQ whole bar plus QR prime and another complement and PR complement and complement. So we can write y is equal to, so PQ plus QR plus PR. Then y is equal to 1. This y is equal to 1. So now the option 2 or more of the input PQ are 0? No. So 2 or more of the inputs PQ are 1. So if any 2 inputs are 1, then y is equal to 1. So if any inputs are 1, any 2 or more inputs are 1, now 1 into 1, or assume PQ are 1, okay, 1 into 0 plus 1 into 0. Now assume, right, okay, P is equal to 1, Q is equal to 1 and R is equal to 0. So in this case we will get y is equal to 1. Simply the option B is correct. 2 or more of the input PQ are 1.